Jared, this is Nina, this is Jared, and that's Evan. And we are Team Gauntlet. And we made up a little acronym for that. The one we came up with is glove apparatus using new technological leads imminent today.
Our mission statement is we want to empower consumers with innovative, high-quality virtual reality experiences to advance the way that we interact with computers. We kept this at our core as we were developing this project.
So before we get into the meat of our presentation, let's give a little background on virtual reality. Virtual reality as a concept first emerged in the early 80s, about the same time as movie Tron came out, that sort of thing. But 3D graphics at that time had not matured to the point where they could deliver on the promises that they made. And as a result, in the mid-1990s, interest in the subject collapsed, about the time that Virtual Boy Lawnmower Man came out, that sort of thing. But today, the subject is undergoing a resurgence in popularity, primarily being driven by a device called the Oculus Rift, which is the first promising device in the field of virtual reality in nearly 20 years. And from that, we were inspired to create the VR glove.
Okay, so the VR glove is a virtual reality glove, and what it does is it gives us a virtual representation of a physical hand in a virtual world. The whole point of it is to track the finger movement and absolute position of the palm. It also, our intention is to make it a fully interactive controller and eventually take it to market to become a consumer product. Products that were on the market and kind of are now are on opposite ends of the spectrum. You have the cheap products that are toy-like. They're not very good. They don't work very well. And then you have the industrialized, specialized products which cost tens of thousands of dollars that were developed by NASA and Lockheed Martin. And what we want to do is create something in the middle, a good product that works well, that we can afford, everyday people, for gaming and whatever you want to do with it. How our product solves problems. First thing, a natural method of interaction. In virtual reality, pretty much what you see is, it's just your view. You don't see any part of your body. So what we did is we created something that allows you to visually see your hand, give you some kind of feedback and more in-depth immersion. This also eliminates disorientation. Some people get dizzy, they get nauseous when it comes to using the Oculus Rift or virtual reality environment. And also what we decided to do was to minimize the cost by shifting a lot of the complexity into software. It takes away a lot of bulk and makes it more streamlined. Okay.
Okay, so when we were designing our device, there were a couple of key points that we wanted to hit. The first one was we wanted it to be low latency. The threshold for human detection between what you see and what you realize is about 40 milliseconds. And we wanted it to be below that threshold. We also wanted to have spatial tracking, which means how your hand moves in your environment rather than the articulation of the fingers. We also wanted to have one-to-one finger and hand motion. If you do this in reality, we wanted it to do that in the virtual world. If you bend your finger this much, same thing. And finally, we wanted it to be a consumer-level device, which means that we have to be able to manufacture it using cheap and commonly available components so that it would be inexpensive for the consumer as well as durable so that you could use it without fear of breaking it too easily. Next slide, please.
Okay, so here's kind of a list of the parts we use to make this a reality. We used, for our finger articulation and detection, we used a product called resistive bend sensors. And we used an Arduino microcontroller for our signal acquisition and processing. We use a product called a Razer Hydra, which is an off-the-shelf computer game controller that does absolute positioning pretty well, and so we kind of borrowed that functionality. We created 3D models for the computer in a piece of software called Blender, and we kind of tied it all together and with the Unity game engine, which is what it sounds like. It's a piece of software that renders a virtual environment, but it also has a useful functionality of being able, there's a lot of plugins for it, so we could tie all our hardware in through this one interface. And of course, we visually output, we display on the Oculus Rift headset.
So there's three major components in our hardware, basically. First, we have the virtual reality glove. That's the part that's actually connected to your hand. And that information, the information of those sensors that we have on the fingers are sent to the computer through a USB connection. Now, at the same time, we have the Razer Hydra, which is our positional tracking system. That as well is connected through USB to the computer. Then the Unity engine processes that information and outputs it through HDMI to our head-mounted display, which is the Oculus Rift. That in turn sends USB feedback to the computer about the user's head position. Now we use the Arduino Micro. It's a small microcontroller because we didn't need a lot of power. We're doing most of our processing on the computer side. So we chose something that's small, easy to use, and affordable. It's an 8-bit, 16 megahertz microcontroller. But the really interesting thing about this microcontroller is that it has native USB, which is much easier to use than just a standard microcontroller that uses FTDI to emulate a virtual port. It does have 20 digital I/O ports, but the thing we're really interested in is the analog inputs. That is how we're getting our signals from our sensors that are on each finger. And it's very easy to program. It uses the Arduino library. It's readily available, you know, very easy to use, and all this stuff works just one-to-one with this microcontroller. Now on the computer side, we're using a plug-in for Unity called Uniduino. Here's a picture of the configuration screen for it. It's very easy. You can change each pin, whether it's an input and output, whether you want analog, and it reports the values to you right here. It uses a piece of firmware called the Firmata firmware that makes this pretty easy to report. And it asynchronously reports ADC values at a sample rate determined in the firmware through basically on the Unity side, it's a virtual COM stereo port on that end, but it still uses the native interface in the microcontroller.
Okay. This is the component that provides our absolute positioning, the Razer Hydra. It's the off-the-shelf, commercially available piece of equipment that provides 6 degrees of freedom position tracking. What that means is that it has 3 axes for both rotation as well as 3 axes for position tracking. And the way it accomplishes this is via induction. There's coils in both the hand receivers as well as in the base unit. It's easy to use, it's plug and play, and it's also easy to integrate into Unity since there's an integrated plugin available for use provided by 6S. Makes it nice. And for our head-mounted display, we're using the Oculus Rift. The particular model that we're using is the first generation dev kit. Provides 1 kilohertz sampling rate head tracking. It's used both glasses, has a bunch of interchangeable lenses for different base and head sizes, and it provides an output resolution of 1280 by 800 split across both eyes.
Okay. So one of the important things we had to do was finger tracking to really capture the movement of the fingers, and we did that with the device called a bin sensor, which it's manufactured by a company called SpectraSymbol. They're about 2.2 inches long, which is about like that, and they're resistive. And what that means is the resistance of the sensor varies with the angle at which it's bent. And fortunately for us, I did some testing on them because it didn't come with a very detailed data sheet, and the relationship between the bend and the resistance is pretty linear. And so we decided to treat it as such in our code. And we connected to the microcontroller with a really basic voltage divider circuit. And so the problem was, one problem we faced is, because we were using a voltage divider, when you have one element that varies in resistance and everything else is